Okay, so this is the mission briefing for the Forces and Simple Machines mission. The premise is that the Canadarm is like an arm like this, and it is seized shut. So what we have to do is we have to be able to pry it open so that we can do a repair job on the Canadarm. So in terms of background knowledge, the students can look up and research the Canadarm if they'd like. The point of this mission is really to study forces and simple machines. What we need to do is we need to be able to amplify a force that we're applying. So an astronaut in this scenario can apply a force of 400 newtons. That would be like lifting about 40 kilograms on Earth. But that force is insufficient to pry open the Canadarm. That's going to take a force of about 2,000 newtons. So what can we do? Well, we have to figure out a way using perhaps a lever with a fulcrum, or using a system of pulleys or something like that, some sort of machine that allows us to amplify the force that we're applying. Those are the straightforward choices, a lever or a pulley. We'd have to have two endpoints for the pulley and a rope going back and forth between them to amplify that force. So however the students choose to do this is fine. What I suggest is doing like a scale mock-up. So the example that I gave here is if they could lift a weight of 200 grams using a 40-gram weight, that would demonstrate that this approach works. So they could demonstrate that either using a lever or using a pulley system. So that's the basic idea of this. One thing that I really like to emphasize when studying these forces and simple machines is that there's this interesting trade-off between the amount of force you apply and the distance over which you apply the force. In physics, we call the product of force times distance work, and to do a certain amount of work, you can apply a large force over a short distance or a smaller force over a longer distance. So if you think of a teeter-totter, for instance, if you wanted to lift your teacher up on the teeter-totter, what you'd do is you'd have your teacher down at the bottom end of the teeter-totter. Your student might go up on the top end, and they're going to stand on that and apply a force over a long distance. That's going to raise the teacher up a small distance. The product of force times distance is the same, so they're applying a smaller force over a larger distance to lift the teacher up a small distance. So there's a trade-off between those two things, and you can see the same thing with pulleys. If you want to do a lot of good work with a pulley applying a small force, you're going to have to pull an awful lot of rope to do it. So that's just an extra detail to this investigation that it might be nice to discuss with your students. What we want them to do is come up with a plan, show that it works on the ground, and then we will figure out the details of where to attach things up in space. But we want to know that it works on the ground, and then we'll be able to suggest that plan of action to the people at Mission Control who can convey that up to the astronauts on the space station. That's the idea of the mission. Good luck.